Right, this is Edexcel Statistics A-level Specimen Paper, Paper 1, which is just probability and that kind of thing. So today it says, during the mornings at a computer centre, the time in minutes between successive job submissions could be modelled by an exponential distribution. So what I'm hoping is that you've either got this or you can pause before I get started and then you can have a look at the question and we'll see what's going on. But an exponential, it's telling you lambda 0.4, so I'm now going to go and check my formula book. That looks a bit sad. So here we got the croissant, then the exponential. So the exponential mean is 1 over lambda. So they told me lambda is 4. So and then it says state the mean time between the successive jobs. So the mean is 1 over lambda, which is 1 over 4, same as 0.25. Over to you, it doesn't really matter how it works. And this is obviously a bit of a mean time between the jobs. And the time is in minutes, so it's a quarter of a minute. So it's all 15 seconds. Or any of these answers is absolutely fine. Okay, ideally you want minutes next to it, or say it's actually 15 seconds. That would be better. Okay, for such mornings, find the probability that less than 1 minute will elapse between successive jobs. Job submissions. This is only 2 marks, so less than 1 minute. I'm going to go and have a look at my formula book. Exponential, less than or equal to, but it's continuous, so that doesn't really make any difference. So I know that the probability that x is less than 1 is 1 minus e to the minus lambda x, because that's what the formula was said over there, which is 1 minus e to the minus lambda. Lambda is 4, and this is where people go wrong. Not the mean that you just worked out, it's the 4. Minus lambda x, x is 1. So I'll put that in my calculator. Here's my calculator, turn it on. So I do 1 minus shift ln to get the e to the minus, I put 0.25, so easy to put that in, times 1. Okay, I'm not sure I agree with that. Oh, it wasn't 0.25, was it? That's the whole thing. That's what people are on. And look what I've got there. 12. That's better. Okay. So I get, that's what I've written down, this is what I've just put in there, 0.9816843361, which is approximately to 366 0.982. Okay, so that's another 2 marks. Next part, give one reason why this exponential model may not apply to the time in minutes between successive job submissions at this computer centre during afternoons. Okay, so this model, or this thing, has been a model of mornings at the computer centre. So really, time in jobs, time between the jobs, may be different in the afternoon. Okay, so the time between successive jobs may be different in the afternoon compared to the morning. Okay. That's absolutely fine. And then there could be the rate of the calls when we're thinking about an exponential. The rates of the calls may not be consistent in the afternoon. So that's the other thing. Does it still follow an exponential distribution? Or the croissant side of thing, are the rates of the calls different? That's fine as well, because it means the same thing. There could be follow-up calls based on problems from the early morning calls, and therefore they also wouldn't be independent, which is another criteria for a croissant and hence an exponential. Okay, so that should be enough for your 4 marks.